running.
Okay. So this is the density lab for. I chose this lead cube here. I guess I know that it's lead, and gonna measure the dimensions here to get the volume and measure the mass of the lead cube. Okay, let's get going. Yeah, this may or may not show up. I'm measuring 3.1 centimeters in one dimension, and since it's supposed to be a cube, 3.1 in any one of the other directions. Yep, 3.1 centimeters. Here I could do, I mean there are random errors, so is it really 3.1, is it 3.15 or 3.05? I really don't know that, so I may want to attach a random error to it, 0.05 centimeters perhaps. I could make a systematic error. My ruler here doesn't start exactly at 0, but the 0 mark is a little bit over here, so if I don't pay attention to it, all of a sudden I come up with only 2.9 centimeters, and I may want to pay attention. I should pay attention to that to avoid these kind of systematic errors. With the measuring tape here, I guess it's kind of obvious where the 0 starts, and usually on a ruler it's 2. Of course, the other systematic error that I could have is, how do I know that this one really does measure 30 centimeters or 12 inches, or did they perhaps manufacture a ruler that is shorter or longer than what it should be? I really don't know that. That's a systematic error that I cannot take care of unless I put these two next to each other. And I see actually these two here work out just fine. 30.0 centimeters is 30.0 centimeters. And then I would have to trust that both of them are manufactured correctly. Okay, so that's how I measure the distances, the width, the height, the depth of this, or length of this cube, 3.1 centimeters. Here comes the mass. For the one that you get, there it is. It's a little bit different for the spring, holding it vertically versus holding it horizontally, because the 0 marker shifts a little bit. So depending on what you're measuring, you have to make sure that in the vertical it's going to be zeroed out, because otherwise, if you don't do that, you again have a systematic error. And you do that by adjusting this tab here at the top. So there we go, 0 centimeters. So that could introduce a systematic error that you want to avoid. Another one that you could have is, how do we know that this spring here is perhaps not too weak? Well, actually we don't. Here we really don't have anything to compare it to, so we just have to trust that the measurement apparatus is good. Okay, so here I'm going to put my lead cube on here, and I'm measuring, holding it still, 355 grams, plus minus couple 3 grams. That would be my random error, because I don't know exactly how I measure, how accurately I measure it. So that would be my random error, plus, let's say 3 grams, plus minus 3 grams. I do the calculations later on in a different recording. Of course, you have your own samples, and just using another one. This was lead. This one is a mineral called galena, which is actually lead ore. So it's kind of lead oxide. And this would be the irregular shaped one, where I can't really measure the dimension. I know it looks a little bit squarish, but it's not completely. So I'm going to do a different kind of method. First, I'm going to measure its mass, and I come up with 47 grams. And that's a little bit estimated here. Make sure, well, actually my tab is just a little bit off. So I'm going to do this again. So what I'm doing here is something you have to do too. You have to kind of troubleshoot a little bit. Oh, I do come actually up with pretty much 50 grams, plus minus a couple of grams, I guess. And now what I'm going to do is I immerse it in water, which gives me the apparent mass when it's immersed, and I'm coming up with 45 grams, plus minus 2 grams. And again, I will show the calculations later. Because my mass difference here between 50 and 45 is relatively small, you will see in the calculations that my accuracy is not that great. Okay, and that's what I wanted to show on these, and as I said, later on in a different recording I'll show you the calculations.